Hi, my name is Doug Drexel, and I am a developer evangelist with the database group here at Oracle. Today, I want to talk about full stack development using the new Oracle 23C Docker container. Full stack development is a methodology used for creating mobile and web applications from start to finish. Full stack developers handle all aspects of a project, from user interface to server-side programming and database management. It enables small, focused teams to work on individual services and enhances the overall flexibility and efficiency of the software development process. It's great for developing microservices as part of a cloud-native application. Some of the popular stacks currently used are the LAMP stack, the mean stack, and the MERN stack. I am going to propose a new stack called Owen that is comprised of the Oracle 23C Docker container, a variety of web clients supported by Parse Server, and Parse Server itself, which is an Express Node JS application. If your web client is React, this would be a full JavaScript stack. So let's talk about Oracle 23C database. This is a developer release of the Oracle database, which is a free version. It provides developers with early access to new application development features coming to Oracle 23C, including innovative functionalities like JSON relational duality and JavaScript stored procedures. Of course, it has a lot of other things, but for the purpose of this talk, these are two features that I think would interest full stack developers. The JSON relational duality is the ability to define JSON readable and writable views on top of an existing SQL database. So if you had an existing Oracle database in SQL and you wanted to expose some of that data to your mobile and web applications, you could write JSON views across the existing SQL tables and use that to access the database. The other one is JavaScript. So Oracle has the idea of stored procedures. You can put functions into the database. In 23C, we support JavaScript for writing server-side database functions. So, I mean, really with that, you go React, you have JavaScript in React, you have JavaScript in the Parse server, and if you want to write some custom routines to make available to those developers, you could write JavaScript actually in the database, a true JavaScript stack. Like I said, this is focused on JSON. This is one component of the Oracle database. I wrote the storage adapter for Parse Server using the Node.js APIs. Here's a link to the JavaScript APIs. So there's a lot going on with JSON in the Oracle database. But let's look at Parse Platform. Parse Platform is an open source framework for building web and mobile applications without having to manage the entire backend infrastructure. It's commonly referred to as a mobile backend as a service. You'll see it supports a wide variety of mobile and web SDKs. I've used JavaScript, Flutter, GraphQL. You have Android, you have Swift, somewhere in here. This is a powerful feature of the Parse server, I think, the supported SDKs. But let's move on to this. So this is our Oracle storage adapter. It's a pluggable storage adapter that goes into Parse server and interfaces with the Oracle database, the local database. All right, so before we get into building this stack locally, I just want to point out a few things from the current 2023 Stack Overflow Developer Survey. JavaScript continues its streak as the most commonly used programming language. And from the same survey, Node.js and React are the two top web frameworks and technologies. And these technologies are all part of this stack. So over the rest of this video, I'm going to build, run, and use this full stack locally on my Mac OS. Okay, let's store the Oracle database image. It's a simple Docker run, name free23c, listening on port 1521. Password is welcome12345, and you download it from the container registry at Oracle. No authentication needed because it's free. So hit enter. Okay, let's check the status of our container, and we will see that our database container has successfully booted. Took about a minute. Now, you're going to need to download SQLCL. This is sort of similar to Mongo Shell for Mongo users. This is a tool for interacting with the database, an administrative tool. So let's go back here, and let's just make sure our database is up and running by connecting as sysdba. You'll notice here the username is sys. We're using the password we specified on boot, localhost with the port, and then there's free PDB1. This is the default database instance that comes when the container is started. You can have multiple container databases in a Docker database. So you can actually have multiple development groups, service development groups working against different database instances that are related to their service, which is kind of cool. But right now we're going to attach as systemdba because we're going to need to run some grants for the actual database administrator, PDB admin. But here, let's just make sure we can connect. All right, it's looking good. Good, we're connected. Now, let's run a query. I mean, really, it does a lot, but let's just run a simple query just to show that everything's working. And you'll see that as systemdba, we can look at all the user tables that make up this database, right? It's really quite a powerful user. So let's quit out of here. I mean, the grants that we want to apply to the administrator of the free PDB1 database instance could be done here on the command line, but it's easier to do it as a script. So I have a script here, soda, that has the commands we need to run to enable JSON development. So we want to alter the session for our default container, and we want to grant a few roles and then get out. So how do we do that? Well, basically, we run the same command that we use to log in, except we have this at the end, the @./soda, which pipes in the script. So let's just run that. You see the session's been altered, the grants have succeeded, and this database is ready for local JSON development. Next, we need to build the server. And to build the server, we're going to need a node installation. And the easiest tool I've found for that is the Node Version Manager. It's very easy to install and use and allows you to easily switch between node versions on your machine. So simple to install. Run a curl or wget, whatever works for your computer, and then find a terminal. I've already installed it, but if you type npm list, you'll see the different versions I have installed on my system. We are going to be working with the most recent release of parse server 7.0.0, and the node version recommended for that is version 20.11.1. So to use that, you just do npm use version 20.11.1, and then npm list, and you will see that my system is set to that version of Node. Okay, let's build the server. Okay, so let's get the source and build the server. The server we're using is the parse server, which is part of the parse platform, which is an application stack based on Node.js Express that is kind of a mobile backend as a service, where it's just a bunch of APIs that any mobile or web developer would use to create their application, including APIs that support like mobile specific thing like push notifications or global config, etc. It's a pretty full-featured server stack. So the first thing we're going to do is grab that server source code from GitHub. The latest release is 7.0. So let's clone that. All right, we're going to clone that into a parse 7.0.0 repository. Okay, so let's change into that. And here is the server code. If we go down, as you can see, there's a directory called source. If we cd into source/adapters/storage, you'll see that there are already two storage adapters, Mongo and Postgres, and we want to install the Oracle storage adapter into this directory. And to do that, that comes from currently available under Oracle samples Oracle adapter parse. That's where the storage adapter code is. I'm currently working with the parse team to make it an official adapter with parse server. There are some things we're doing to modify the build to support database adapters as storage adapters, as external adapters. Right now, both the Mongo and Postgres database storage adapters are part of the parse server. So we're splitting that out, fixing up the tests to run that way. And that should be done in the next few months for sure, as 23C is released. Oracle has a Node Oracle DB library for interacting with Oracle databases, and I have basically built the storage adapter on top of this API. So what we want to do is we want to clone this repository into the Oracle storage adapter. And now we have the Oracle directory. We cd into Oracle. We need to remove the .git file because that messes with the build, and then go back up to the root. Okay, so now we have the parse 7.0 source code, and we have the Oracle storage adapter code. Next thing we're going to have to do is install two dependencies. One is the dependency for the Oracle DB libraries. So let's go grab that and install it. That EBAD engine is just saying that if I was building parse 4.2.0, the version of Node that I'm using does not fit the requirements. Okay, so now we installed the Oracle NodeDB packages, and we're also going to install the parse file storage adapter. And this is a simple adapter that does file storage to the local file system, right? And this is like, if you wanted to store audio or video, you would store it into the local file system. On other cloud providers, like we have this stack that deploys to OCI, the Oracle Cloud, and in there we can configure that to use an S3 adapter, file adapter. But for now, it's all local. We're going to use local storage. So let's install this. Okay, copy. Okay. And now we have our dependencies, our source code. Let's build the server. We just run npm CI, and in a minute, under a minute, we will have a server build. While that's building, let's go take a look at the SDKs. So you can see here, Parse has a variety of SDKs that it supports: Objective-C, Android, JavaScript, Flutter, GraphQL, REST. It really is full-fledged. Okay, our server is built. Let's get ready to run it. Prior to running the server, you're going to need to download the Oracle Insta Client for whatever platform you're developing on. I'm developing on Mac OS, so the latest Insta Client there is 1916. All right, that's what I have. Okay, to run the server, we have to create a config.json. So let's take a quick look. I've already cut and pasted this. You'll see that we have app ID. Every application uses that as an identifier. That's part of the HTTP headers. We specify the port of the server. We mount GraphQL. We set the path. We specify where the file adapter is. And this is kind of the new code. We specify where the database adapter is, and that is where we cloned our database adapter into from Oracle. And then this is the URI for connecting to the Docker container, which has the prefix Oracle DB, the administrator of the PDB called free PDB1, which is an instance in the container database. And we have the password and the connection string. So that will get us connected to our local container. Also, before running this server, we have to export Oracle DB version. We saw that the latest Insta client was 19 for Mac OS. So all this work here is intended to work by default with 23C. So if you're using an earlier version of the Insta client, just set this to 19 or 21. And then boot the server. All right, so we point at our Oracle client location. Let's put this over here in this window. Point at our Oracle client location, npm start, and feed it to config.json. Boom. All right, you can see as it's starting up, a wallet was found, which is needed to connect to a remote database, which I will show in a subsequent video. But now you can see the server's successfully booted and connected, and it's exposed on port 1338. Our server endpoint for the parse API, the GraphQL endpoint, and the playground. Next, test the server. Okay, so let's run a request against the server. I just wanted to reiterate the large collection of supported mobile and web SDKs. Flutter, JavaScript, REST, GraphQL, iOS, Swift. It's all there. But we're going to use REST today. I'm going to run a curl, very simple. My personal preference is the JavaScript. I think that's the best one. But what we're going to do is just run a simple curl command against the server, right? We're giving it our application ID, and we're sending across the document, JSON document. What will happen on the server side is the game score collection will be created and this document will be added. So let's do it. Here it is. Boom. There we go. So that's what you get back, an object identifier for create at the time of creation. Next thing I want to show is it actually made it into the database. Here's our running server in there. So this time we are going to connect as the PDB admin, which is the default administrator for the default database instance, free PDB1. So we're going to use SQL to log in. And there we go. And now we have access to commands like soda list. All right, that lists the collections currently in the database. The collections with the underscore preceding the name are all parse internal collections. And game score is the collection that was just created. It's one record, so let's check that. Get what's in game score. All right, here's the key of the record. Document, document. And let's take a look at it. And there's our data. So really, very simply, we've set up a full stack locally, database, server, and a simple front end, and then start developing a web or mobile-based application. Okay, let's go and look at the dashboard. Okay, so I am going to use the parse dashboard GitHub project, and this is really super simple to install. I've already installed it, but just run that command. And after that command is run, if you have a running instance of the server, you should just be able to start the dashboard with this command, which gives the application ID, the master key, the endpoint for the parse API, and the endpoint for the GraphQL API. Let's hit it and take a look. Okay, there we go. As you can see, this is the landing page. We have one application called application ID. So let's go take a look at it. All right, in here you have a browser, so you can look at your collections. These are internal collections. This is the game score document that we just entered. So you can do CRUD operations from here on collections and documents in collections. This is a webhooks tab. We can create a webhook. We've actually created a webhook from here to call Spring Boot microservices deployed to a platform that my team also works on. This is real nice. And the ability to expose Spring Boot services as mobile or web endpoints is really easy. Maybe I can do a video on that one. So let's go back here. We're not going to create one right now. You have your push console where you can create an audience. You can preview your pushes. Actually done this using the Apple notification network. So maybe we could do a video on that. People are interested. And let's see, one of the other nice things here is for development, because we have the playground endpoint. So there's two API consoles, a REST one, a JavaScript one, and a GraphQL console. So let's take a look and run a few GraphQL queries. Okay, now we are going to run a few GraphQL commands against the database through the playground. So GraphQL, one of its benefits is it's just one endpoint that you always hit. There's no long sort of concatenated set of actions or descriptors as in a REST request, nouns and verbs, I think. So if we look at the Documentation Explorer, you'll see that there are two types of generalizations in GraphQL. One's the query, one's the mutation. One's a get, and mutations basically do everything else. Create, delete, update. If you look at the mutations, you can see that some are already available for some of the internal tables. Look, here's one for game score that was automatically created when I created the game score collection. But now we are going to close that, create a course class. So this is GraphQL syntax for creating classes or collections in a NoSQL database. So let's hit run, and boom, looks like it worked. Nothing ugly over here. And then let's create a course in the collection. I'm gonna hit run. Oh, wait, let me show you this. Right, oh, let me go grab the schema again. I'm gonna refetch the GraphQL schema. And now I'm gonna go back into Documentation Explorer, into mutations. And you see the dynamic API doc. Since we created a collection, there are now these APIs for doing mutations on the collection. So that's kind of cool, real-time documentation. So let's run the query. Boom. And there we go. That looks like success. Let's go check. Let's go in our browser, look up course. There it is, our collection with the new data. So this is really handy, these API consoles in prototyping code, really. Okay, so that's it for this video. I mean, I took you through, we ran a full stack with Oracle. We have the server component, we have the database component, and we have the front end component, and really whatever you want. As you can see, here's the course game score. So yes, I hope this video convinced you that Oracle also has a full stack development offering. I probably went through a lot of links here. I'm going to put them in the comments for the video. All right, thanks for watching. Bye.